All right, welcome to a rare late night video. Got a bit of time here. In the last video, we went ahead and added those code changes back where we can now use the latest version of pandas because we use the .concat method rather than the .append method for adding onto an existing data frame. In the older versions, the way you did that was you did the data frame dot append and then the new data frame you want to add to the end of the old one, like we can see here. And then if you want to preserve what the indexes were, even if the indexes don't make sense, if the row can be labeled 1, 2, 3, and then be labeled 1, 2, 3 again, you can have it that way. But if you wanted to automatically update the rows so that when you append a new data frame with 3 rows to an existing one with 3 rows, and the existing one is 1, 2, 3, the new one will be appended automatically with 4, 5, 6. So that's what ignore index equals true does. It it relabels the indexes in chronological order starting at 0. So the thing is, this is deprecated. So what that means is that it's no longer supported in new versions of pandas. So if we were to go to Python 3, and then we were to say import pandas, and then we would do pandas dot dunder version. Oops, and we have to do that with the correct spelling. So pandas. The version is 2.2.2, so that's the latest version. So I'll define data frame like I had before. So df1 equals this. This is a data frame here. And then we learned in the last video how to define a data frame. So to define a data frame, you need to feed it a object that has indexes. For example, a list has indexes. So then in the index, for each index of the list, now you need to feed it the object you want represented in the data frame. So you can just give it a straight like this, and it will know what to do with that. We can see it just labels it as 0. The other thing you can do is feed it, instead of just a string like that, we can feed it a dictionary, and now we can label the column. So to label the column, you define keys that have the column name. So if we col_1 for column 1, and then the value is hello, as it was before. So, and then we print off df1 then. Now we can see that we have a column named this, and we have the row is still the index from this list. So you can pass it different kinds of data types, but the data types have to have these attributes so that it knows what to make the row and what to make the column. Alternatively, you can explicitly define what the rows and columns are. But even if you do that, you still need to provide it with an iterable object. So if we do a help on pandas data frame, we can see there are parameters defined. Parameters are the definition of the class, or the it's a definition of what arguments can be passed to the class or function or class method. So these are the parameters. Now when you call it and you feed in data like this, these are arguments. So that's my understanding of it anyway, which was developed before the advent of ChatGPT. So I might do a check on that at some time, but not now because it's not relevant. So if we look at what you can pass to a data frame, so by default it doesn't pass any data, so none, and then it looks for, and then it has the Oh yeah, so this is an operator, I think, or operator. So index is a keyword. Columns, copy. So we can see we can pass it index, and we can pass it custom columns. So one of the ways to do that is to add an argument. And now what we can do is we can say index equals row 1. But in order for this to work, the length of the index has to match the length of the object that you turn into a data frame. So we're turning a list object into a data frame. So by default, the rows would be labeled the number of the elements in the list. So there's only one element in the list. Indexes in a list start at 0. So this first element in the list is at index 0. So that's what the index would be named. But we're doing it a bit different. We're passing in an explicit naming for the indexes. And since we only have one index, we're going to just have a list of length 1 with one entry in it. And we're going to call it row underscore 1. So now when I print off that data frame, we can see the row is custom named as well as the column. And we can add on to the to it as well. So if we go here and we go call to, and then we do world, and we have to use the proper syntax. So this is a dictionary, so it has to be defined as such with these curly braces. And let's see what happens if we do this. Oh, so see what this says? It says it's a value error. Length of values does not match length of index. And we can actually see more info. Yeah, so we can actually see quite a bit more information relating to that. So what is the problem? Right here, we fed it custom index labels, but we didn't feed it all of the labels that it needs. So let's have this say row 2. And now we notice there's no error anymore. And we notice that it looks the way we would expect it to look. Now there's something else to notice that is kind of interesting. For column 1, we only have a value in row 1. For column 2, we only have a value in row 2. So that's something that is kind of I was not prepared to give a demo of, but I think from what I've learned up until here, I'm really happy with how this demo went. So I'm actually going to take a quick pause, and then when I come back, I'm not sure kind of where I'll go. I might try to figure this out, but I might go back to the reading because I just want to make progress with the book, and I'm happy with so. Yeah, so from here on out, how I learned about this is dir and help. These are two critical things to get used to using in Python. When you import a library, the first thing you should do on that library is a help, because the documentation for it is built in right there. And then you can do a dir on the library as well, and see what methods are available to use in that. So that's how I learned this, and yeah, that's it for this brief lesson. I'm going to take a quick break, and when I come back, I will keep reading the book. All right, I'm back. So, you know what? Let's take a little bit of time and let's just try to fill in these values. So, I know that you can add another row by adding more entries to this dictionary. Now, I'm not sure how you can add another column though. I know that you can add more entries to a dictionary, like so. So if we name this column 1 as well, and then we say world here, okay, and then we try the same thing over here. Let's just experiment and see what happens. That's always something I highly encourage doing. That's really the best way to learn, and the only way to learn sometimes, actually. So I'm pretty sure you can have another duplicate key, but if you cannot, that'll be the first thing that we find out in trying to do this. Okay, so we've got a syntax error here. It's expecting a colon after a dictionary key. I did not give it a colon. I gave it a comma. All right, and there we go. So let's see what our data frame looks like. Oh, so now this is interesting. It looks like all we did was overwrote the value. So before, we can see what it was before. It had hello here. Now it has world there, and it had world there, and now it has hello here. And that's because it looks like we overwrote what was in there. So let's try something unique this time, and let's give each of the keys a unique name. All right, and how does that make a difference? Where's my end? There it is. Okay, so what that did is that gave us a new column for each key that we have defined, even across indexes for the list. But we can see that the first two that we define are in this row 1, and then the next two that we define are in this row 2. So let's experiment some more. Let's make that it all be in one dictionary and see what happens then. Okay, so now I've edited it, so this is just one big dictionary instead of 2. All right, so now we can see it's quite a bit different. In column 1, and it looks like I skipped column 2, that's okay. We've got hello. Column 3, we've got world. Column 4, we've got world. Column 5, we've got hello. Now we do have 2. Now this is kind of interesting. We have a greater number of indexes now than is in the list. Now we only have 1 index in the list, but we defined this argument to have a data type with 2 indexes. But that worked. There was not a problem with that. Now what happens if I were to add another dictionary? And we're going to say 6, and then we're going to say test. Now what happens if I do this? Okay, so now we have another row added, and we have test belong to, sorry, we have another column added named 6. We have the same amount of rows as were before, but now we have a value in row 2, which makes sense because this is a 2. This has a 2 elements in this list now, so our index is fine. So if we go ahead and delete this second entry, now we're going to get that error again saying that the length of values does not match the length of index 1, and we see index is 1 and then the value is 2. So we definitely have to have the same number, But it looks like you can actually add more here. You don't have to have the exact same number. You can have a greater number of values in the index than in your a greater length of index than in your values for your data frame. So same problem here. Well, that's interesting. That's really interesting. Why was it working before when there was a discrepancy? So here we have one dictionary here with the open and curly brace, and we have one list with one value. That one value is a dictionary. The dictionary has key value pairs. It has 1, 2, 3, 4 sets of key value pairs, but it resides inside of a list with only one index. But here we have a list. We have indexes we're showing have 2, but somehow in this case the index doesn't have to match. So that's kind of fascinating. I'm not sure what's going on with that. Huh. So it obviously depends on the dictionary to some extent, whether or not this has to match. Wow, and you can even define it with 3 different rows. That's interesting. Well, why the heck can you do that? What if we do it with 5? Because then there's more. Then there's one more than there are key value pairs in the dictionary. Oh, well then it still works. All right. Well, I officially do not know what's going on, and it's back. Oh no, it's meant to be backwards because it's like that. Okay, but that's the end of the demonstration. If you're interested in pandas, then you'll have to go and learn about it more yourself. And I need a quick break. I'll be right back. All right, I'm back. I'm getting tired, so I'm not sure how much more I can do. So let's pull up use case 5 and get to that point in the book, and then try to knock off some reading. If we knock off just a few pages, that will this is a really meaty one, so that will help out later. Okay, so we got pretty far in the reading. It's I think it's the out correlations, but let's double check. Nope, it's the candidate correlations. Okay, and we just got a warning here, so we can ignore warnings and continue on. Okay, and now we're at the candidate correlations. So, yeah, everything's looking good. All right, so every page knocked down is progress. There is a special case of interfaces, which are the aggregated interfaces. Usually, if you compute the correlation index of egress traffic data among the member interfaces of a bundle, they will likely be highly correlated and also highly correlated with the total traffic of the bundle itself. Ultimately, the hashing mechanisms produce a quite fair distribution, and all interfaces follow similar patterns. Therefore, we may not be able to know, because of this, how each member is connected to the other endpoint, because their correlation indexes are going to be very similar. Nevertheless, you will be able to know that those interfaces belong to a certain bundle, and that the bundle is connected to the bundle in the neighbor node. If we take any example from the candidate correlations list and graph the egress traffic on one interface versus the ingress traffic on the interface that has been selected by the algorithm as connected, this is what we can observe. All right, so the next cell, we're going to print out some graphs here. All right, looks good to me. So we got the output traffic, and then I'm not sure what this is on the bottom. Oh, it's time. It's time, and we can see it's in scientific notation, so it's quite a bit of time. So we have spikes and dips in the traffic as expected, day and night, holidays, that sort of thing, seasonality. They are extremely similar, which is what we expected. The candidate correlations list effectively contains the topology of our network. We can now, with the topology information, build a network graph and visualize our network. Network graphs are extremely powerful data structures to capture entities and their relationships, and in networking and clouds are a fundamental piece for analytics. Let's build and visualize a network graph based on our candidate correlations list. We are going to use a NetworkX library, a very popular one to create and do operations with network graphs. There are other libraries, but this one is quite convenient. All right, so let's use this freaking... I've heard of this library before. I've kind of wanted to use this. NetworkX... yeah, let me advance the bookmark and then get to this cell. So this cell, well, let's get to the money cell here, where we get a nice pretty diagram. So I can advance this and then go back and read. The logic is very simple. We create a graph object. We will add nodes to the graph, uniquely identified by its name. The nodes are the routers in the network. Then, for each of the connections discovered in our topology discovery algorithm, we will add an edge in the graph that connects two nodes together. So the edges in the graph will be the network links. Now we can visualize the graph. All right, so plt.show, we should get a graph that looks like that. All right, and then let's do one more thing. I want to get in the habit of doing this. So one thing I definitely preach, so I should be practicing more, is using the built-in tools you have in the Python interpreter shell to learn more about your requirements for your project that you will install, you will import and use. So one of the requirements for this project is NetworkX. But I haven't. Okay. Okay, so now that it's installed, we have it imported. So the first thing I would definitely encourage doing is take a look at the help, because this is the true. This is the source of truth for really what that help is, and oftentimes you can find the complete documentation right there and get the definitive source. This is, and you know that this is for your version 2, so this is really where you want to go first to get help. After that, you can go through and you can look at the submodules. This is also something that ChatGPT, I think, would really excel in. You just take this whole thing and just paste it into ChatGPT, and I guarantee you, you will get pretty good results with that. Let's try that. It's not. One thing we can do is let's see here. Okay, well, so the problem is I can't. Oh, is this Vi? No, it's a pagination thing. Oh, here we go. Yeah, so if you hit H, this, I think this tool is less, so you get the help menu for this tool is less that we're in, which shows pagination. So you get help here. So there might be a way to select all and then copy all that. So that's what I'm looking for in the help. Okay, don't see it there, so I'm gonna hit enter for more and enter for more again. So that's searching. This is jumping. We want to see selecting. All right. Well, again, this is what ChatGPT is basically designed for. How can I select all and copy all in less in Linux?
In Linux, selecting and copying all text in a terminal or file can be done using various methods depending on the context and tools you're using. Here are some common methods. Terminal, command line, using tab xclip or X.
Sorry, so no, you misunderstood me. The tool I am using is less. Within the context of this Linux tool, which is called less, how do I use the options within this tool named less to select all the text and copy it to my clipboard?
Here's how you can do it. Method 1. Using less with xclip or XL, copying all content of a file viewed with less for clipboard using xclip or xsel. Use the cat command to pipe the file content to xclip or xsel directly. This bypasses less but achieves the same result.
No, you misunderstood me again. What I mean is within the context of less. So let's say I enter the command less file name. Now from here, how do I copy all and how do I select all and copy all? Only give me instructions for after the command less file name has already been issued.
I understand now that you want to perform these actions while you're already in the less viewer.
Yes.
Unfortunately, less itself does not have built-in commands to select or copy text
God
directly.
damn it. That's bad. Well, okay, I can't do it, so that's not good. Man, really? Okay. Wow. I mean, I guess what you could do is do help like this and then network X. And then is it easier to do it like this? No, you still get the same problem. You're still in less. Well, is there a way to set up Python so that Is there a way to set up Python? Is there a way to set up Python so that when I use tools like help, it doesn't display the output in the program less and it displays it in something better where I can actually copy and select all what's in there? Okay, how do I do that?
Yes, you can configure Python so that the output commands like help doesn't open in the less pager but instead displays directly in a way that's easier to copy and select text from.
Oh, that's cool.
You can achieve this by changing the fader setting for Python's help system.
Cool.
Here's how you can do it. Method 1. Using pager environment variable, you can set the pager environment variable to cat, which will print the help text directly to the terminal without using less. Set pager to cat. In your terminal, before starting Python, set the pager environment variable to cat. Then start Python. Now, when you use help, the output will be printed directly to the terminal. Method 2. Using Python's PyDoc module, you can also modify Python's PyDoc module settings within your Python script or session to use cat instead of less. Modify PyDoc settings in your Python session. Use the help function. This will print the help output directly to the terminal. Method 3. Custom function to display help. You can create a custom function to display help information using PyDoc directly in the terminal without using pager. Create custom help function. Use the custom help function. This will render the help documentation in plain text and print it directly to the terminal, making it easy to copy and select all the text.
Okay, so I tried doing it so that I can get it in the showing up in my files in here, but that didn't work. It just opened a new tab, didn't work the way I wanted it to. So I think cat would be a lot better. Okay, so now the help on it. Okay, so now, so I definitely recommend doing that. Otherwise, you'll have a lot of trouble actually pasting this in. So now let's do a new chat, and we'll just paste all of this in there, and you can see how powerful.
NetworkX is a comprehensive Python library designed for the creation, manipulation, and analysis of complex networks. Here's a detailed overview of its structure and functionalities based on the provided documentation. NetworkX overview name, NetworkX. Version 3.3. Description. NetworkX is a versatile package for studying the structure, dynamics, and functions of complex networks. It offers a wide range of tools and algorithms for network analysis and is well documented on its official website, NetworkX. Package contents. The package includes several submodules and functions.
Yeah, so now you've got a comprehensive prompt for working with this. So along with the documentation, along with you're hitting it from all angles, and then you've got ChatGPT as well. So let's continue on with the reading now that we've got that pretty graph to display. Bouquet is, and I think that name comes from like flowers, like a bouquet of flowers. Bouquet is a more powerful network graph visualization library that allows you to build the graph and have some level of interactivity with it, such as zoom, highlight node properties, etc. Here is one example using Bouquet for our backbone network topology. So there we go. This is how you use Bouquet to draw a network graph, and we get something that looks quite a bit different here, and it looks like it's actually interactive now. So let's definitely take a look at that. Okay, so here's Bouquet. So we got a problem. Bouquet is I'm guessing Bouquet is installed. So the problem, so it's an attribute error. Unexpected attribute size to circle. Okay, well, let's just get rid of it then. So the attribute is size, and it should be coming from well, it calls it out directly. Line 14 in here, network graph dot node render. Oh, here, size. All right, well, let's just get rid of it. See what happens. And it runs perfect. So yeah, now we can move it around. Now we can zoom in on a node and see like what connections it actually has, what the node is. Something's obviously missing from mine. That size seemed to have been pretty necessary. So let's try. Let's play with this a bit. Let's see where this circle comes from. Okay, so I think it comes from the import statements. Yeah, so it comes from here in the import statements. So let's play around with that a bit. Just in the interpreter shell, just as I just demoed to learn more about it. So we're going to do a pip using a magic method. Pip install BOKEH, like a bouquet of flowers. I think it's where that name comes from. Because, it's it's showing visualizations that sometimes might look like bouquet of flowers. All right, so next up we're going to paste in the statement from the notebook, which is right here. All right, and it looks like it's frozen. It's not allowing me to do anything. So I don't know. Now it's saying that there's one file to analyze. So that could be why it's taking so long. So it'd be nice if I could delete that or somehow get back. Okay, so it looks like pasted in now. If I hit enter, interesting. Yeah, so this there's something going wrong here where it's I don't know what is going on, but it's not following along. You know what? Let's trash this terminal and start a new one. All right, and now just my computer's dead. So I think what's happening is this is eating a lot because it's interactive. It's just eating a lot. So let's take a look at my task manager and the yeah. So we've got 100% disk. So it's just eating up all my memory and disk. So I'm going to stop this. So I interrupted the kernel. We're going to shut down the kernel like this. Yep. And then let's take a look at those metrics again. Okay, so now my disk is still at 100. That's interesting. Okay. So let's shut down VS Code. Okay, so now my disk is at normal levels. So something happened with VS Code. It looks like the memory is still being eaten up as well. We're still at 70% with the memory. We can see VMMEM WSL is eating up a lot. So let's search for that. Yeah, high memory. Yeah, what is this? Yeah, so I've got a virtual machine. Something's going on. We can do a task kill on it. Yeah, so it's still unfortunately really eating up a lot of memory. Huh. Huh. All right. Well, it'd be nice to get that memory back. I think I'm just gonna end task. I don't know what it is, but oh, well, that's good. Interesting. Well, that's no good. Okay. Well, anyways, we're very nearly done with this use case 5. So let's just finish the reading and end the video. As you can see, all PE nodes have 4 interfaces connecting to C1, C2, C3, C4. The topology visualization is not the best one, but you can sense that our simple mathematical computation based on some very basic data, interface traffic has resolved the network topology in a way that is fully vendor protocol or technology agnostic. No machine learning, though, in this case, but it is the power of the information contained in the data that, if used conveniently, can provide interesting insights. In this case, the entire network topology. Takeaways. Some of the key takeaways from this exercise. Do not feel too persuaded by the power of machine learning. There is definitely power, but the power is indeed in the data. You can extract a lot of insights from the data, even with some basic mathematical operations like in this case. Most of the time, the main challenge is getting the data presented to your algorithm in the form factor required. This is where you will spend most of your time. In our example, the correlation part was easy, but we had to do a fair amount of data manipulation, interpolation, alignment, etc. to get where we needed. Computing something with matrices directly rather than vectors or scalars is always preferred. There can be orders of magnitude of difference in terms of processing time, especially in the context of Python, which is not a particularly fast executing programming language. I would really encourage you to become familiar with network graphs with libraries such as NetworkX and the different algorithms to deal with graphs. In our network and cloud context, it is extremely important. Further work. As I've mentioned, there are certain caveats in the algorithm we have applied, such as the aggregate interfaces. It would be interesting to extend the logic to properly deal with them. Playing and learning about network graphs is also an area I would suggest for further work, both in terms of visualization, but also analytics. This exercise may be a good starting point for that. All right, so that's it. We're almost 2/3 of the way done with the book, so exciting times for sure. Use case 6 is next, which is what are the driving factors for problems in my network? So yeah, exciting times. We're almost done with this book. So thanks for watching and stay tuned for the next video.